thank you all for being here. My name is Carolyn Finch. I'm the program manager here at the Charleston Digital Corridor. And I am thrilled to announce our second ever Tech Throwdowns. We had our first one 2 months ago. Very great success with Tom Wilson. This time is our first to have two speakers battle it out. And I think they do have boxing gloves. So we're excited to see how this new format works. On our left side, we have in the ring Brian Gilbert from Spark, who will be debating on the side of Scala. And then on our right side, we have Mark Gunnels, who will be doing Clojure. So thank you both. Just to cheers. A few housekeeping things. Most of you know next Thursday is our annual bash we'll be hosting. If you haven't registered yet, please do so very, very quickly. We'll be closing registration by Tuesday. But I think most of you in this room, I will be seeing you on Thursday. We'll be having our unveiling for the I5K poster, so look forward to that. We have some great shots, and we'll keep that a surprise until next Thursday. Next month, November, I can't believe it's already almost November, we are starting our member meetup series. It'll be members only, and you'll actually need your email to sign up. So we'll limit it to members, make it very exclusive, a nice way for all of us to kind of get together, meet up once a month, maybe quarterly. We'll see how it goes, but look forward to that to start next month. Lastly, in January, we'll be doing potentially our next battle, iOS versus Android. So keep your ears posted.
I'll be a lot worse than this one.
Yeah.
We've got two very spirited on both side individuals, so that'll be a fun one too.
I
So
think, before you get off the floor, most of you guys know, actually Tom's here, both Tom's here, Tom Brady and Tom Wilson. Where's Tom? Oh, there he is. So he's going to be teaching, in a few minutes he's going to be teaching the Couch database class next door. So, we've got the code camp, so Scala, Brian's teaching Scala, I guess. Brian, when is, that's what?
December
6th.
6th, yeah.
Yeah, so for you guys who want more Scala, there's a day, 9:30 to 3:30, just on Scala. So I would say, basically, when you come to these things, you kind of learn a little bit, just if you want more, send us info at CHS Code Camp, just send us an email through Code Camp, and just to give you an idea, we've gone from 9 instructors to 18 on our way to 22 here shortly. So we want to hear from you guys, and just throw it at us, because it's phenomenal that the guys like Brian, guys like Mark, will take time to teach these to people who are interested in learning about it. So thanks, everyone.
all right. Without further ado, we'll start with, we have an extra slide to go through the, I'll let Mark discuss it.
So I was a debate nerd in high school. Nobody gasped. So we chose to do an Oxford-style debate. Usually what happens is you vote at the FERC on whether you want Scala or Clojure. And then the winner is actually the person who swayed the most people from one side or the other. The burden rests on the affirmative position to prove the proposition, which is why I screwed you and let you go first. And the proposition is Scala is demonstrably better than Clojure. And I'd just like to note that Scala lost in every category last night in the language throwdown.
All two?
All two.
Thanks for the unbiased approach.
Thank you. That's how I roll.
All right.
Start with Scala.
All right, so I'm Brian Gilbert. I'm going to be arguing on Scala's position during this throwdown. I'm kind of giving you a little teaser right there. Scala's better. I kind of know what's going to happen here. You can curl me. There's my API endpoint. And without further ado, let's start with a joke. So, what do you call Clojure developers? Anybody? They're called Clojerks. Oh, get it? Because they write Clojure and they're jerks. Okay. So, Scala is statically typed. One of the reasons why you would use Scala over Clojure is you have a static type system that has your back. But this is not your average type system that you would normally get in a lot of other languages I'm not going to mention. It has built-in type inference. It also has variance, covariance, higher kind of types, and abstract types. So I've got a little code sample right here. You can see I'm creating a person, has a name, age, and has a list of children right here. You'll notice no type annotations. The compiler can figure this out for you. And you can see right down here, getting children, I'm mapping across and converting this into a list of ages, and I'm just getting the max, which is going to have 4, which is going to be the oldest child of Steve. This way, you can easily write really succinct code, really expressive code, but still have the compiler have your back. This eliminates a whole class of errors that you would normally run into if everything was completely dynamic. And it also allows you to interop with other people's code with a lot more confidence. If you're in Clojure, you wouldn't have that confidence. Scala is multi-paradigm. It's functional. And you can see that by this simple composition. This is kind of all I need to put here. You can get a range of 1 to 100. You can filter odd numbers. You can map. You can double all of those numbers, and then you can reduce and multiply all of those guys together. And this, that's kind of all I need to say there. The big part that is a sell for Scala is it's also object-oriented. You have full object orientation at your tips, and you have a lot more powerful object orientation than you have in something like Java. You can see this right here by this simple hierarchy right here, where I have a abstract class. It's an animal. The animal can speak. The animal can move. I can have traits here. Traits are like interfaces that have implementations that can have optional implementations. The cool thing about this is I can mix and compose, mix in objects at runtime in a fully type-safe way. So I can create a duck or a parrot by sharing these flying behaviors, or mixing in a quacking behavior in the case of a duck, chirping behavior in the case of a parrot. So you can easily do this, and this is very powerful because I've used this many times. This allows you to easily factor out common behaviors that can be used across different modules. I've used this for like a storage behavior. You can easily have a storage behavior that will allow you to plug in different types of storage, where you could be storing to RAM, you could be storing to disk, you could be storing out to HDFS if you want to, and all you have to do is plug in these particular behaviors, which is very cool. And then this is called self-typing, which basically says a behavior has to be typed as an animal. So you can only mix it in with other animals. You can't mix it in with like a random object. And this is just the tip of the iceberg. I'm just kind of giving you a taste here, but there is very, very, very strong object hierarchies. And one other thing cool, I mentioned earlier, variance and covariance. Unlike Java, you can create a list of person. Then you can have if child is a subclass of person, list of child is a subclass of list of person. So you can easily dynamically work with lists in different contexts where you're expecting supertypes of that list. One, to me, of the biggest sales, even though it didn't win last night at the language shootout.
We chalked it up to the implementer.
What's that?
We chalked it up to the implementer, not the language.
Yeah, that's fine. That's true, actually. So Scala is efficient. It's very, very easy to move down to the metal on the JVM. You can use raw Java arrays very easily. You can work with unboxed primitives very easily. It's very easy to predict when your ints, doubles, your primitive values will box and when they won't. Because if you're working in a very high performance context where like a very tight loop, boxing will kill you. So I mentioned this specialized parameter. One thing that even gives it an advantage that allows Twitter to, that's supposed to say specialized, not specialed. So one thing that allows Twitter to write libraries that have abstract algebra that outperforms raw primitive operations a lot of time in Java is you can specialize classes. So if fun fact in Java, if you have a generic class like a list and you put an integer in it, that integer is automatically boxed. That's just what happens. So in Scala, you can specialize a class on specific types so that it works with any type, but it generates a specialized version for integers or doubles. So that class can work generically with raw primitive integers. You can also easily ensure single dispatch code. Basically, you can ensure that you're going to go straight to a method and not through a lot of indirection. You can easily compile jump tables from switch statements as long as you meet a few small criteria, and the compiler will check that for you if you annotate it. Scala is very good at imperative bottoms where needed. The cool thing about it is it's multi-paradigm. You can have a very functional top that's very clean, it's very clear to read and write, and then where you have to, you can easily drop down to an imperative bottom where in certain spots of code, in certain type loops, you can easily write in a very imperative way and get all of this performance very easily. And then I'll also say that Scala has Akka for concurrency and parallelism. It has actors, it has agents, it has STM, it has futures. You can scale out across multiple machines, and as of 2.10, which came out the end of last year, Akka is built directly into Scala 2.10, so you can use it without having to add it specifically as a library. And this allows you a lot of power. Oh, and I was copying and pasting a Hello World in Clojure and I accidentally put it in my slide deck.
No, I'm glad you put that in there.
Yeah. Let's see. Java interoperability. Both Clojure and Scala have Java interoperability. The big difference here is that it's a lot simpler and a lot more organic. You can easily subclass, subtype, work with Java libraries as natively as you can in Java. You can also work easily with Scala libraries from Java. That interop is huge. Being able to introduce this into larger projects and work with it, you can do this a lot easier because it's not all or nothing. You can put Scala in small spots and then you can slowly evolve it and rewrite more of your application in Scala. It's also nice to be able to give back to the Java ecosystem when you write really cool libraries in Scala, which you'll see tons of them that Twitter have, and a lot of other libraries that you'd be surprised to find are actually written in Scala and not Java. All of the object-oriented concepts map from one to one. And then Scala adds excellent implicit conversions with Java collections. So you can import some implicit conversions, and it'll automatically convert array lists to Scala lists or maps to Scala maps, back and forth, very easy. Which I didn't mention, but Scala has immutable data structures, persistent data structures. I didn't really mention that as a high point because Clojure has them as well. And this kind of hits another high point, which is pretty cool, that implicit scope is a very cool concept in Scala that allows you to define variables in implicit scope, and then as you progress through, you can use those you can pull them out of implicit scope, so you don't actually have to pass them around. This is all done in a very type safe way that's checked by the compiler, but you can put a database connection in implicit scope and then just call database functions, and they can access that database value from the implicit scope so that you don't have to pass this with every call or call it on a database connection or anything like that, which makes code a lot more clean. Scala has macros. It has very good macros, and the cool thing is these macros are compiled and they're all type check as well. I just got a few examples. Play2 JSON inception basically allows you to define simple case classes, generates all of the parsing code, all of the reading code, all of that for you directly from the classes versus the other way around, like using an object mapper. So you have this compiled representation of your code, and it is very easy to type check, work with in any context, and then when you're reading, it does automatic validation for you. Spire is a mathematical library from Twitter, which allows you to do very advanced mathematical operations in a very high performance context. This is normally meant to be used in very, very, very large data sets. Scala async. Scala async allows you to write imperative-looking code using features, and it has a macro that basically rewrites that code and basically provides implicit continuation, so you can write this huge block all synchronously, and it translates into async code. Scala axial loops allows you to work with iterators, Java arrays, all of these things, and you can write a simple for each. And normally for each are a lot less efficient. The most efficient loop on the JVM is a while loop, and it will automatically convert Java array iteration directly down to while loops with a counter, which is the fastest way you can do it. And a type loop, that really matters. And then you have quasi-quotes. Recently, with the last version of Scala that came out, quasi-quotes are included, and it allows you to define a macro and basically do it in a way where you're basically writing out the code as a template, and then you can fill in macro spots. It's actually very nice work. Scala has a very large ecosystem. You have Akka, you have Play2, both are provided by TypeSafe, which got $14 million in funding towards the end of last year. So there is a very fast cadence with development, and Scala is developing at a very rapid pace. You have Spray, which is an awesome API server. You have Finagle from Twitter. Twitter's entire backend is written in Scala, and it's all Finagle, which is a very high-performance server framework that allows you to create servers that work, endpoints that work with a variety of formats, Thrift, JSON, any of those. Scalding is a very cool framework written by Twitter as well that works on top of the cascading framework on Hadoop. Summingbird is also from Twitter. It's very high performance counting analytics library. You've got Lyft, which is a MVC-like web server. You have Spark, which is positioned to be next generation of Hadoop. And then you have many, many more. And if you look at the adoption, look at these. These companies, a majority of these companies have moved the majority of their whole infrastructure to Scala, and these are companies with large data concerns, with huge backends, with traffic that most companies could never dream of. And it says something that so many of them have been centering around Scala as of late. And you can just see tons of those there. Oh wait, I think this is from Mark's. That's not supposed to be in there. Okay, and what else? So those are some of the high points, but there's so much more. You have type classes, duck typing, self-typing, implicits, value classes. Value classes are awesome. They allow you to write classes with primitive types in them, and it compiles down, the class goes away, and you're working with raw primitives and raw functions, which is very nice. You can pass around something that you say is a point of two doubles, and it will ensure everyone's working with that point knows it's a point, not just two doubles or not just an integer. So it allows you to ensure type safety across your entire platform, even though you're just working with the raw primitive value. Lazy streams, pattern matching, string interpolation, option, try. Option allows you to work with code that might be null, and you are explicitly encouraged to handle that case. Try can encapsulate a operation that may or may not fail. Whenever you go to use the value, you explicitly acknowledge the failure case. You have for comprehensions, which allow you to generate streams, and so much more. So, conclusion: go forth and make Scala, not Clojure.
You have one more slide.
I've been lying to you.
You
The
still got
slide's
6
lying
minutes.
to you. Oh, I still have 6 minutes?
Yeah, you want to? Or you just want to go?
So I went a little fast. Does anyone have any questions about any of this?
Are you claiming all of that is unique to Scala and not Clojure?
No, not all of it. I'm just I'm showing the breadth that you have. Though, so I know several of them are. Lazy streams, pattern matching, I actually got as library. Option and try are, implicits are, any of the typing and type classes and value classes, those are all unique. No? Cool. Well, you get your chance. Cool. Well, I think that's all I have. Just leave it in there.
Good job.
Thanks.
So the first thing I want to point out is how much Brian got wrong. Clojure is not, by definition, statically typed, but like most things with Clojure, because it is a Lisp, you can add that stuff easily. It just becomes a library. So there's been a huge movement in the community towards core.typed. And core.typed is, again, allows you to do, and let me restart so that it's fair. So one of the nice, and I do want to say one of the nice things about the Clojure community is, and the Scala community too, is that they're willing to adopt from other things. So a lot of people were complaining, hey, we don't have statically typed, and there was a huge, this guy, Ambrose Bryant, who, if ever, I'll show a picture of Rich Hickey. He's like a younger Rich Hickey. Everybody jokes that he was cloned from Rich Hickey. So he just, as part of his dissertation, built out core.typed and was adopted. He's a very smart guy. Clojure can be object-oriented if you want it to. It's like any of the lists, the common list, the CMOS, you can build your own object-oriented things, and people have. They've just been generally shunned by the community because nobody, and the Clojure community really likes mixing object, really likes mixing behavior and code. It's just, why do it? And you talked about traits, and Clojure has records and protocols, the abstract data types. But again, there's always this thing of why mixing up data and behavior just leads to, and I think you even made this point, object hierarchies, which I'm not sure that's an advantage. What has been found is generally simplicity comes from composition of types rather than large object hierarchies. So Clojure tends to avoid that. Any of the unboxed metal stuff, you can do that in Clojure. Clojure has great Java interop. I've written EJBs in Clojure, for God's sakes. I don't know if you get more Java than that. He talked about Akka. Akka is a fantastic library. It's amazing. A lot of its implementation details, both in kind of the Scala immutability and in Akka itself, borrowed from Clojure. And there's a huge interop and just cooperation between the communities. Jonas Boner, is that how you pronounce his name? The originator.
Bonnier.
Bonnier, I'm sorry. I'm from the South, we can't pronounce Jack. But he and Rich Hickey are big admirers of each other, and they've kind of swapped ideas. It's actually interesting to see them talk. Basically all the compiler efficiencies. I think your Twitter backend is a little bit overstated now that they bought Backtype, which was it was an acquisition that they made of an analytics company, and the main guy, do you know Nathan Mars?
Yeah.
Yeah. They basically bought it for him, and he wrote Storm, which is more not necessarily a Hadoop replacement, but a kind of a stream processing, and it's written in Java and Clojure, but most of their analytics stuff is now supposedly, at least he was saying, implemented in Clojure. I can't verify, it's just anecdotal. And then your what else slide, sorry, I'm getting old. Clojure has most of that. So let me start. So I'm Mark Owens from Jack Russell Software. My boss is probably terribly embarrassed right now. He's sitting right there. You can find me on Twitter at Mark Owens. So the proposition before us is Scala is demonstrably better than Clojure, and the burden of proof is on the affirmative. My contention is Clojure and Scala are different expressions of the same values. And where they differ, the differences are valuable. And that's because there are a whole class of problems that are easier to think about in Scala than Clojure, and vice versa. So I would say neither is better, and it's crippling, I think, to think that one is. And I think the tech community tends to do itself a disservice and I do this to Tom all the time when if I make fun of JavaScript and throw away the idea of callbacks, but callbacks are essentially a primitive in kind of a lot of concurrency and parallelism implementations, and so to dismiss one is to make sure that you don't understand. So I don't know. I tend to start a lot of shit like that, but I never really mean it. It's more of an exploratory, which is like the language throwdown we had last night was everybody do a different implementation of a concurrency, and then everybody came in and learned. Like, I think it was awesome. So the 3 arguments I have to support my contention are, by definition, and I did set him up a little bit, he's lost. And then by virtue of the Hegelian dialectic, and I just wanted to use that term, it's a really simple thing, I feel like the proposition is incorrect. And then I want to real quickly go through some of Clojure's virtues. And what you'll see is a lot of the things that Scala values, some of the OO principles that you talked about, Clojure embraces, but they just embrace in a different way. And again, I think those differences are valuable. So by definition, the proposition fails. So let's look at the, I need to get one of these. I've never presented one. It's awesome. So let's define our terms. So Erdarsky, who is the inventor of Scala, had to say this about Clojure. From what I can see, it is a very well put together language that brings the power of Lisp to the JVM in a practical package. I threw in functional because that's kind of the selling point. So again, Clojure is just a Lisp that runs on the JVM. It has access to everything that the JVM has. The interop is fantastic. And I've a couple of times used Clojure to use the Akka library. So what do we mean when we say demonstrably? It means able to be proven. And if everybody, if you read XKCD, you know what that word is. But that means by definition, you have to be able to prove that Scala is better. Think about that for a second. We've got a computer science professor back there. Like, is there any type of experiment that you could come up with to really prove that, given the variables? No, okay. So he's lost. I just threw in better of superior suitability, advisability, desirability. And what I think that this misses is, again, there are a whole class of problems that are easier to think about in Clojure, particularly if you're doing kind of data flow things. And this is just by analogy, so I can't prove that either. Than Scala. And there's just fantastic intellects on both sides. So I think to say one is better than the other is kind of crippling. And then here we go. Has a study been performed? If not, then you haven't proven anything. You may have persuaded, but not proven. And then I just like that little face. I wish I could make that face a lot of times, particularly with my son. So here's the byhead. So I just say again, the differences are valuable, blah, blah, blah. And this is the important point, and I see this a lot in the community. And I think more and more, and I would say particularly at conferences like Strange Loop and things like that, where there's a multitude of languages basically talking about concepts than the languages themselves. This idea of like, oh, Ruby is better than Python, I'm sure all of you guys remember those days. Or everybody used to hate on Java until everybody depended on the JVM at least, and Java for the implementation of their language of choice. So what is Hegelian dialecticism? Basically, it says in kind of any evolution of ideas, you start off with a thesis, somebody proposes an antithesis, and then there's a synthesis. What this used to be, I forget who, like some very evil people used this to condone war, because the idea was you had one side, you had the other, and they tried to out-innovate each other to kill each other better. But really, what he was talking about is this idea of cross-pollination. So for the longest time, object-oriented kind of ruled everything was object-oriented. And now there's been so that's our thesis, there's been this rise of functional, and there's this synthesis. And which I would argue is, if you take Java on one polarity and Clojure on another, Scala kind of meets in the middle, and Clojure can evolve into a more Scala. Scala would be your synthesis, and then Clojure can also evolve, if you want it to, into the synthesis. So, did that make any sense, or did that just work out in my head? Don't worry about it. So, here's Erdarsky again. There are things we like so much in Clojure that we copied them. For instance, the data structures for sequences and hash trees. I believe there are and will be many other areas of fruitful cross-pollination. And you see this all the time. For instance, the core async library, a lot of that came from C#, combining C# and Go. So I think that's one of the areas that, and Scala does this too, where looking at and just understanding different languages and then adopting the best. So again, it was that thesis, antithesis, and synthesis that led to that. Whoops. Well, I think that should, no, sorry. So I like what Brent Ashworth did. And I think he was he created JavaScript, right?
Oh, no.
Is he the PHP?
He's Brendan Ike. He's the guy who wrote the pedestal.
Oh, yeah. Which actually...
yeah, that was Brendan Ike that created
Oh, that's right, this guy. So he said, I really like this quote, "We should choose languages based on how accurately they allow us to think about the problem we are trying to solve." This is actually something that gets discussed a lot of times in the Clojure community. And kind of the common idea that's arrived at is if you're modeling something in the real world, like a person, and this seems counterintuitive, avoid object-oriented because you're just really representing data. But if you're modeling something that exists in the computer, like a button, and this is used a lot in, then something like Scala or the DOM, things like that. So I think it's again, I have a hard time going with better, and maybe it's just because I'm old and worn out. So with languages, there is no verses, I feel. I think it's only a dialogue. And very, very few times is there a better. Everything's better than Perl. There's just a better language for a particular domain. And so I think the proposition is a false choice, and you have to find it false, therefore. So in this interview, this guy Fogus, who's brilliant, asked, in order for Scala to win, does Clojure need to lose? And Oderski's an awesome guy. He's just like, no, this is silly. Does everybody recognize this? If you don't, you have no soul. I will judge on things like that. Python? Monty Python? Anybody? No? Okay. There's hope for the younger generation. So again, here's Twitter and Netflix, and I'm glad you brought up Twitter. They moved predominantly from Ruby on Rails because they needed the performance gains, moved to Scala, and then as they started to get more and more of their business needing the analytics, they went out and got Nathan Mars, who is a huge Clojure development, and they brought all of that infrastructure in-house. So things like Storm, a couple other things they now depend on. A friend of mine works for Netflix, and again, they started off as a big Scala shop, and Clojure slowly, particularly in the areas of data analysis, is becoming more and more. And it's interesting, a lot of the data science companies in New York, I was up there visiting with a friend, and more and more are adopting Clojure. And I think, again, it's just that one language is better for one domain, one language is better for another. Better in quotes. So what are Clojure's virtues? First, there's this whole movement towards simple over easy. And I'm going to define those terms because they're very important, and I think they help you make a good distinction when thinking about a problem. Again, it's hosted. I don't know that we need to go over that, other than, again, I'll skip those slides. I've written servlets, EJBs. I basically ripped out a system I wrote in 2002, a JE system, and replaced it with a Clojure, and they never knew, nor did they care, because, again, it could just deploy on the same platform. Again, the O principles of encapsulation and polymorphism are embraced by the community. There's just expressed in different ways. We have this idea of many functions, few types, and then it's a Lisp, which... So, simple over easy. There is a Rich Hickey talk that I think everybody should see, and not because it's not language specific, it's basically paradigm defining. And so what he says is oftentimes in the community we mistake simple for easy. And so if you think about something like Rails is easy. Like you download, like you do the, what is it, gem install Rails now, I can't remember, it's been forever. And then a lot of things are easy, like interacting with your database, things like that, until things get hard. And then if you want to break out of that Rails paradigm, if you need performance, things like that, then it gets more complex, and you start to see the interweavings of the library. They're well broken up and a lot better in 3 and even more better than 4, and they're evolving into essentially what Clojure does into their very there's loose coupling between them, and they used to be very coupled. So I would say something like Rails is easy, meaning it's near at hand. Simple, however, is having few parts, or a simple braid is actually the thing. So what the Clojure community does, and the Node community does this too, is large frameworks are kind of set to the side, and you have libraries that do one simple thing. And so when you create a application, you're composing from libraries, and because you have these simple types, it's easy to couple them where needed. And actually, if you look at some of the relevance implementations, they're one of the big supporters of Clojure. They basically, it's just a series of workers. So one worker does one and one thing, throws it on a queue, the next one picks it up. Even if it's all contained within this simple single application, there's always a queue. Even in Pedestal, you've seen. And the original Clojure Script 1 implementation was all based around queues. So never mistake simple for easy. And the Clojure community really, really emphasizes that. And that's one of the reasons the mixing of behavior and data and O stuff, even though you can have an O, it's not. So again, I'm just re-emphasizing. But this is what I want to talk about quick, and why I'm glad you threw in the slide that you did mocking the parentheses. Hold on one second. I did bring you something. This is the only thing I really dislike about Scala. Scala is the Perl for the 21st century, so I got you that. So let's get it out of the way. This is what I see except this is what other people see. Everybody focuses on the parentheses. And that's because everybody wants your language to be easy. Lisp is very, very different, but it's extremely simple. And once you get over that initial hump, it's amazingly simple. Look at this. Think about what you're seeing here. There is no real syntax other than the parentheses. Everything is a function. This namespace is a function. This is a function. This is a function. Everything is a function. So what's that? It's a macro. Macro is really a function underneath. So all you're looking at is everything is two parentheses, the function, the arguments. That's all there is. That's all the syntax. And there's been a lot of allegorical stories of, especially I've heard both people at Twitter and Netflix talk about, we can teach new programmers Clojure faster than Scala. It's allegorical. I don't necessarily buy it, but it is a dead simple syntax. That's all there is. Function, arguments, surrounded by parentheses. The other nice thing about this is you don't have to have necessarily a special macro language, because Clojure is defined by its data types. This is a list. This is a vector. So what you're looking at is essentially an abstract syntax tree. So it makes it simple to parse and simple, dead simple to manipulate. The other thing too is, and this helps out a lot with composability, you have essentially 4 different data structures. You have lists, vectors, maps, and sets. Most of the implementations for, let's say, something like if you're writing is everybody familiar with rack on Ruby? I don't know what the Scala equivalent is. It's because the play framework is massive. But again, you compose, and so all you do is the web request comes in, it passes through functions that just transform it, and you just pass maps. So if you want to test, you don't have to have mock objects. And actually, one of my favorite Rich Hickey quotes is, those mock objects are mocking you. Because all you're doing is, it makes it easy to test because you have these simple data structures. So again, hosted, Clojure, blah, blah, blah. This is what I really like. I think secretly I'm a hippie. Clojure can share in the successes of the other JVM languages. Likewise, they can share in the successes of Clojure. Just like Scala has borrowed from Clojure, Clojure has borrowed from Scala. You can define servlets. I don't know why you would. So let's take encapsulation, which I think everybody kind of embraces as so it's essentially a language mechanism for restricting access to some of the object's components. Thank you, Wikipedia. So the first thing is if you want to prevent, like one of the first nice things or advantages of encapsulation is you're preventing a user from setting your internal data to your component into an invalid or inconsistent state. That's really easy to accomplish with a Clojure. Basically, and that's Clojure with an S, not a J. So all you're doing is you pass in. I think I'm done. I'm going to go real quick. So you can do that. You can. Quiet. I'm going to take his remaining 5 minutes. So you can accomplish the same things in Clojure very simply with closures, namespaces, which allow you to define certain functions as both public, private, and global variables, which are massively frowned upon. And then immutability is the default in Clojure. And it is to a degree in Scala. You can say, I want this to be mutable or immutable. You can do the same thing in Clojure, but much more so you have to, it's the default. And so one of the advantages again that people talk about encapsulation is you don't want people to have easy access to your data so they can change it under you. If your data is immutable, they can anyway. So there's no. And then the other thing is the measures that you have to take in Clojure to make something mutable. They have easy mechanisms to enforce validation. So a lot of times your setters and getters your setters are to validate some data before it comes in. Like it's the integers between this and this. It's simple to do. Here's mutability support and thread safe. This is basically software transactional memory. You can do watchers it's basically the observer pattern built in and the validation. I'm going to move on since I only have a little time. Polymorphism, basically abstract data types he was talking about. Those are built in a la carte with Clojure. This just lets you dispatch not on type multi-methods, but the characteristics of the data, which is nice. And then, crap, I'm missing a slide. Protocols and records allow you to build out abstract data types and dispatch on type. And those are incredibly fast, the protocols and records. A lot of times it's nice to go out and just rip out your old stuff and stick that in. Many functions, few types. Alan Perlis wrote it was like the epigrams of something. Programming, he's well known. He makes the point it's better to have 100 functions operate on one data structure than 10 functions on 10 data structures. And what ends up happening a lot of times in OO is you end up with something like that because you're mixing behavior and data. That's not really an advantage. Again, this is, I would say, 1/50th of the number of functions that are available. If you ever want to go look at the Clojure.org site, the API, it just goes on forever, the number of functions that you can apply. And it's really nice because you can take these and just compose them together. And it's a Lisp, which again, depending on your preference, I really like. Because if you don't like the language, you can change it, which we saw with the core.typed. In summary, there's no way that you can prove Scala is better. It's all by allegory and then, or kind of one person's opinion. And again, when it's one person's opinion, it's just because that person's working in a particular domain and they find that one language or another is better. And then Clojure is an extremely elegant and productive language. I wish I could have shown that more. I will say Clojure is better when it comes to Scala in one respect at least. Look at that. Look at that luxurious hair. Rich Hickey's the guy who invented it. This hair. He's also literally the pissiest man alive. It's awesome. So that's it. So I'll just leave that up to look at.
A few minutes for questions. I just wanted you to know, I had an observation. I don't know if any of you guys, if you guys really want comedy, go to C-SPAN and watch the British Parliament sometime.
Those are fantastic.
Yeah, really, that's debating and at its best, right? So it just got, now that we have new desks, so you can bang on them to either oppose or, basically, okay, and if you see that, Mark, if they're opposed to something, they just start making noise to try and drown out the opponent. It's really kind of cool.
And there's no respect for one another. It's awesome. There's none of this might distinguish. They're like, you're an asshole.
Exactly.
It's awesome.
So we'll take a few minutes of questions, and then Tom's ready to fire up his couch class. So we'll start. We'll stop promptly in 10 minutes. So there's questions from any of you guys.
I think he gets 5 minutes response. If
Is there a rebuttal?
Well, I think you planned this whole thing.
I did. I totally said. I was like, I can't
It's
believe
like
he's
this
doing
Oxford
this.
debate. I'm like Googling Oxford debate.
When you were like, I was like,
sure.
oh, I'll let him go first, and I was like, I can't believe he's doing
Yeah, he's
this.
so nice. Like, you go first.
Yeah, questions from anybody? Comments, thoughts?
I have questions. So you guys got into it a little bit, like which segments, which industries kind of tend to feel one language is better than the other. Can you give me just an overview of like which?
Well, so I've used both of them. I actually really like Clojure a lot. Scala as well. I would say the places where I would recommend one over the other. It's kind of, I guess it's in some ways a personal choice depending on how you prefer to tackle a problem. I found that Scala, I like whenever I really need to. I definitely know there's good interop with Java, but it's easier in a lot of cases, at least to me, to do interop with Java, especially when you have to go.
Do you mean
really
easier or simpler?
Huh?
Do you mean easier or simpler?
Easier and simpler.
Way to cover your bases.
Yeah, there you go. But whenever I need to do really down to the middle, and I do find it easier and simpler when working with primitive types. I found it's a lot easier to predict when things are going to box, when they're going to unbox, and using those specialized to, because at Spark I was working on a data store, and I love Clojure for a lot of things, but I feel like certain parts of that data store would be really tough to write, especially the down to the metal aggregation. And I guess I say down to the metal. You're only going down so far since you're on the JVM, but. I feel like that's the case, but then I feel like rapidly getting something going in Clojure is a lot easier. I'd let you speak to some of the really strong places that you found it.
Where I've seen it most adopted now is when people are doing, I hate the term big data, but any type of analytics or machine learning. A lot of, what's the company that just got bought by, there was some big insurance company that bought basically a weather prediction. And that whole, I went to one of Nathan Mars's things in San Francisco, and they were recruiting. They're like, "Oh, you're here? We'll hire you." Like here, they were literally signing people up, and so I find that a lot in any type of data analysis. People tend towards Clojure, I think, just because again, data is data in Clojure. And then what's really, and I know from relevance, and I don't remember what I signed, so I can't. But there are a couple of large retail chains that are moving when they're moving from pure JE implementations, using the pedestal framework, and which I don't like. I think it's too big but they're using Clojure to both redo their websites and their backends, just because pedestal lets you, with Clojure script, it's one language all the way through. Same data structure, so you're never forced to do kind of the implicit conversions. Pedestal just handles it for you. So people tend to find that. Which I don't know if I would write a whole. And for the record, I like Scala too. So.
All right, guys. Until next time. I appreciate you coming out. Thank you, Mark and Brian. It's great. And poor Cheryl, she doesn't know she's been drafted for the Android side of the debate in January.